Now, galaxies form clusters, and here is the cluster to which Milky Way belongs. It's called local group, and it indicates several galaxies that belong to the same cluster. Local group contains maybe 24 of galaxies, and in this diagram here, somebody perhaps jokingly decided to label the distances in kilometers. You see, you need very large numbers. This galaxy here, M31, is Andromeda galaxy, which is slightly bigger than our own galaxy. It's also a spiral galaxy, and it is approaching the Milky Way at a speed of about 110 kilometers per second. Right now, the distance between the Milky Way and Andromeda is about 2.5 million light years. And it turns out that the two galaxies will approach each other and start interacting gravitationally in about 4 billion years, roughly at the time when the sun runs out of hydrogen as its energy fuel. Now, the local group represents what we call poor galaxy cluster. Galaxy clusters that contain less than 1,000 galaxies are labeled as poor galaxy clusters. Those that contain more than 1,000 galaxies are called a rich galaxy cluster. An example of such rich galaxy cluster is a coma cluster, which contains numerous galaxies. And this particular cluster is important because in the 30s, American astronomer of Swiss origin, Fritz Zwicky, he observed the motion of the galaxies in the cluster, and these, in fact, galaxies are gravitationally bound to each other. They revolve around each other, and he concluded that they may move too fast if all of the mass contained in the cluster is contained in so-called visible mass, the mass contained in the stars of these galaxies. And he actually estimated that there has to be 400 times more mass than what is contained in the visible mass. And he named that invisible mass that has to be there to explain the high speed of the motion of the galaxies in the cluster, dark matter. He used German word, dunkle Materie. And again, this notion was again reintroduced in the early 70s. And it turns out that the dark matter is 5 times more abundant than ordinary matter, the stuff we are made of, and the planets and the stars. And galaxy clusters, they form even bigger structures, superclusters, the clusters of galaxy clusters. And the supercluster to which local group belongs is called local supercluster. So here in this diagram here, it's illustrated how one would describe our cosmic address the same way as you would write your street, the town, the province, the country. So we live on Earth, which belongs to the solar system, which in turn is part of our galaxy, the Milky Way, which in turn is part of the local group, the cluster of galaxies which contains the Milky Way. The local group is a part of a supercluster called local supercluster, and the entire universe is formed by a network of these superclusters of galaxies. This photo here represents probably the largest structures that we observe in the universe. You can see that these superclusters of galaxies form filaments separated by voids. And these are the largest structures known to us in the universe, and one of the research topics in the contemporary astronomy, astrophysics, is explaining this large structure of the universe.